In this lesson, I'm going to teach you how to sketch the graph of a rational function without using a calculator. So how we're going to do that is we're going to use all the knowledge that you have attained in my previous lessons about the graph of a rational function. So I'm given a rational function here, y is equal to x minus 4 over x squared plus x minus 20. And there's several steps in sketching this graph here. The first step wants you to find all the vertical asymptotes or the whole of this function. So the first thing you want to do here is you want to factor this rational function. So in factored form, we have x minus 4 over, we have a quadratic on the bottom. So if we PSA it correctly, we get x plus 5 times x minus 4. So there you go. There is our factor form. Now we want to state the non-permissible values of this rational function. And remember, the non-permissible values occur when your denominator is equal to 0. So we actually have two non-permissible values here. One at x is equal to negative 5, which is from the first factor, and a second one at x is equal to positive 4, which comes from the second factor. Okay, so there are two possibilities for these vertical asymptotes here. We can have either a vertical asymptote or a whole. Okay, so those are the two possibilities here. Remember, a whole occurs when you have a common factor on the top and the bottom of your rational function. So take a look at the factor form here. Do we have any common terms that we can take out or we can identify? We do. We have one x minus 4 on the top and also an x minus 4 on the bottom. So this makes x equals 4 a whole in the graph. So it's a point of discontinuity. And x minus 5 is left as a vertical asymptote. Okay, so there we have identified the vertical asymptote and the whole of our rational function. So you're going to actually plot or graph these features here. So we're going to graph the vertical asymptote. It goes right through negative 5, so find negative 5, and it's a vertical line. So show it using a dotted or dashed line. And it's just to help us remember that it doesn't actually touch that line. It approaches it, but it doesn't reach it. Okay, and then we have the whole. Now, I suggest for the whole that we leave it last. Okay, so we're going to plot the whole very last. So we're going to move on to step 2 here. We want to find the horizontal asymptotes of our graph. To find the horizontal asymptotes, you have to make sure you're working with the fully simplified version of your rational function. So we already factored it, which was up here. So here's our factor form, but we did not simplify it. In order to simplify, you're canceling out any common terms. We found common terms at x minus 4, okay? So cancel this out, and we're left with a simplified version of 1 over x plus 5. So it's really important when you're identifying any horizontal asymptotes or oblique asymptotes, you have to make sure you're working with the fully simplified form of your rational function. Very, very important. Okay, so from here on, we actually look at the degree of the numerator and the denominator. So the numerator is a constant, so we have a degree of 0. Okay, and then the bottom, the highest power is 1, so therefore we have a degree of 1. Okay, so comparing these two values here, 0 is obviously less than 1, so therefore we have a horizontal asymptote, okay, at the line y is equal to 0, which is also the x-axis. Okay, so we have identified a horizontal asymptote along the x-axis, so draw that line using a dotted horizontal line. So there is a horizontal asymptote. It's not going to touch that line, okay? It's going to approach it, but it's not going to touch it. Next thing we want to do is identify the intercepts. So this involves both the x-intercepts and y-intercepts. So let's start with the x-intercepts, okay? So the x-intercepts occur when y is equal to 0. You should know that already, okay? But what did we find in step 2? Well, we found out we had a horizontal asymptote at y is equal to 0, which is also the x-axis. So think about it. We are not defined along this line. So therefore, we have no x-intercept since the x-axis is not defined in our graph. Okay, so that was quite simple, but we still need to identify the y-intercept. And remember, the y-intercept occurs when your x value is equal to 0. And we can find the y value by going back to the original function. Wherever you see an x, put in a 0. So we have 0 minus 4 over 0 squared plus 0 minus 20. If you simplify this correctly, you're going to get a decimal value of positive 0.2. So positive 0.2 is going to be your y-intercept. So I'll write that down here. Y-intercept at 0.2. Okay? So now you want to actually plot that point. So find 0, 0.2. And it's actually really close to, really close to the origin. So we're just going to put it right there in black. Okay, so we know the graph is going to go through that point. There's no doubt about it. But we still need to figure out some more points on this graph. So in order to do that, you're going to pick maybe 3 or 4 points, and you're going to find the corresponding y value using the function. Okay, so I'm going to use -6, let's see, -4 and +3. So it doesn't matter which points you take as long as they're not vertical asymptotes or holes. Okay, so obviously I didn't want to pick -5 because I'm not going to get a value. It's not defined. Okay, so pick 3 points and then you're going to find the corresponding y values. So you're going to do that using the original function, which is right there, and you're going to find the y values. So go into your calculator. Okay, so when you find the y values, be very careful. We are dealing with a fraction here, a rational function. So we're going to evaluate -6 first. So go plug in the numerator first, -6 divided by 4. Okay? Okay, so we have -10. And we're going to divide that value by the expression on the bottom here. So we have -6 squared. Okay, plus -6 minus 20. Okay, put brackets around your denominator. And we get a value of -1. So that's the corresponding y value. And now we're going to do -4. So in your calculators, we're going to do the numerator first. So we have -4 minus 4. And you're going to press enter. And then you're going to divide by the expression on the bottom. So wherever you see an x, it's going to be a -4. So -4 squared. Okay, and plus a -4 minus a 20. And close your brackets, and we're going to get a value of +1. So there's the corresponding y value for x is equal to -1. Now I'm not going to show you 3. I have it here already. We have 0.5. So once again, just follow the same steps, and you should get this value right here. Okay, so now let's plot those points. We have on -6, -1, which I will plot right here. Okay. And -4, +1, which is about here. Okay, and 3, +3.5. So that's going to be, oh, this should have been negative. Sorry about that. So it's -3.5. And that's going to be about here. Okay, so we have some points on the graph. Okay, so 1, 2, 3, and don't forget the y-intercept. So now we're going to actually sketch this graph. Now I want you to imagine this. Imagine that the asymptotes are magnets, okay? It's attracting the graph, but you're not going to be able to touch it because you can't touch the asymptotes, okay? So starting with -6, this graph is going to be decreasing as we approach the y, or the vertical asymptotes. It's going to be decreasing as we approach x is equal to -5. Then you're going to be increasing as you approach the horizontal asymptote along the x-axis. Okay, so remember, it's attracted to the asymptotes, but it's not going to touch it. Okay, so now we're going to start at -4, +1 to get the right side of the graph. Remember, it's going to increase as it approaches the vertical asymptote, and it's going to decrease as it approaches the horizontal asymptotes. Remember, it has to go through point 2 because that was the y-intercept. And there you go. That is the graph right there, rational function graph. Okay, but we aren't done. Remember what I said about the hole. We leave the hole for last. And remember, it was at x is equal to 4. So graph, find that point, x is equal to 4. And x is equal to 4 is right in a different color, right? Let's use green right there. So we have a hole. Okay, so when you're sketching your graph, make sure you put a big empty circle right at that point. So there's the hole. It's right at 4 on the graph. Okay, and that's how you sketch the graph of a rational function using without using a calculator.